All right, friends, welcome back to another session of today's event. This will be our sixth session, and it will be delivered by Hasan Savran, who's from the US. He's also an MVP and a Microsoft certified master. Hasan is currently with Progressive Insurance as a business intelligence architect. He also supports various community events like Data Platform Geeks all around the world as well. So welcome, Hasan. Hope you're doing great and good luck with your session. And Hasan, just one more thing, you can also start your video like all the other previous speakers have done. Our audience would love to see you. And yes, and for the audience, please use the Q&A panel in the tab for your questions if you have any questions, and Hasan will be able to take them later on after he delivers his sessions. Over to you, Hasan.
Thank you. Let me share my screen?
Yes.
Can everybody see my screen?
Yes, it's perfect.
Okay, I'm guessing you're not seeing any other stuff here that I see from the Zoom. So thank you for having me today. My name is Hasan Savran, and I'm going to speak about Azure Cosmos DB with you today. And hopefully everybody's going to learn something new today. Before I go in details, let me speak about myself a little bit. As I say, my name is Hasan Savran, and I'm a business intelligence manager in one of the main insurance companies at the United States. And I have been Microsoft Data Platform MVP for 2 years in data platform. And I'm proud of it, and I'm trying to, help the community as much as I can. And I'm from Cleveland, Ohio, which is, well, kind of in the north right now. The weather is getting kind of cold, so I'm not looking for winter, but hey. And also I have developed the 15 years web development experience and 7 years business intelligence experience. You can follow me in following platforms you can see on the screen. And I'm pretty active. I try to share as much as I can. Usually I write about front-end, C#, Cosmos DB, SQL Server. I like to share anything really. So that's my blog out there. You see, I try to write at least once a week. So let's jump into a presentation and let's talk about the Cosmos DB. So I'm going to talk about the history of Cosmos DB first and try to explain everything from the beginning. So in 2010, Cosmos DB was actually born as Project Florence. The reason for Cosmos DB to be actually started was, well, Microsoft is a large company and they're a global company. There are customers from all over the world, and it has those, global applications like Xbox, like Office, or many other applications like that. And they needed to share data between the, users. And SQL Server was not going to cut that because, imagine how much Xbox creates data daily per users, and you need something globally distributed. And they say, okay, we are going to need a new kind of database for this, and they needed like a NoSQL database. So in 2010, they decided to create this project named Project Florence, and they start to work on it. In 5 years came, and this product became stable, and they were using internally. And they say, okay, we have a stable product here, and we are pretty happy with it. Let's actually try to, share this with public and make money, right? Why not? So in 2015, they actually released the Azure Document DB. And that was the place for most of the devs to store their data in JSON format in cloud. And they were able to actually get the data by using a T-SQL like a language. So they didn't need to learn a whole new language to use this application, and they store the data by JSON format. So everybody was happy, and people start to use it. And Microsoft did not stop there, and they needed, some features for themselves internally, and they started to get, feedback from the customers from outside. So they start, like work on it harder, and in 2 years they made some really big changes. In 2017, they released the second version, and they changed the name from Azure Document DB to Azure Cosmos DB. Azure Cosmos DB had, when they released it, there's like, as I say before, many features were released. Like, for example, global distribution was released, multi-model was released, and I'm going to actually cover most of them in this talk. So whenever I, start to talk about the Cosmos DB, people, the first thing I hear from, people is, oh yeah, that's the new database, isn't it? If you look at that timeline here, it's newer, but right now we are in 2020. So you have a database here for like 10 years old. So it's not really that new anymore, and many people are using it. So I'm glad that you are here to actually learn about this, because I mean, that is my feeling and that's my thought, but I think we are going to see Cosmos DB and NoSQL databases more and more in future. Second question I get, so who is using it, right? The first one, I can give you an example, is games. Games, if you think about it, you have users from all over the world. And in many games in these days, they are not really simple anymore. They try to make money and money. So to make money, they sell stuff. So if you are playing a, I don't know, car racing game, they might try to sell you cars, right? So they can go faster. Or if you are, like, there are all kind of games out there. They sell all kind of stuff, like they can try to sell you weapons, so you can actually have more power, or whatever. So you can do all those transactions. You need a database for that, and you can use the Cosmos DB as a database because it's global distributed and it's pretty stable and fast. It's a NoSQL, no schema, so it really works for like games like that. The second one I can give you an example is the e-commerce websites. So e-commerce websites, your database is really the engine, right? If your database is down, really you cannot do any kind of transactions. And especially if you are in one of those special days in the United States, we have, for example, Black Friday, you make a lot of money that day. And if your application kind of goes down that day, that's pretty bad. And also, like when a day comes up like that, for example, a Black Friday in United States, maybe your website kind of, has usually maybe 100 or 200 users per day. That day will come and you might end up like 10,000 and 100,000 users. So you need to kind of a database for this to scale up and scale down easily. And Cosmos DB gives you that. The third one is IoT devices. So IoT devices, usually the companies are using them for to actually catch the problems before they occur, right? So, they might put sensors, for example, in cars, and those sensors sends constantly some kind of, data to the database. And when the database, we will analyze it and we will see if the sensors, sending us some weird signals. And if it does, maybe we need to service that car. The problem with that is those sensors sense those signals usually, depending on your application, but maybe like every 30 seconds, every 1 minute, maybe every 10 seconds. And those are usually JSON documents. They might be small, but since we are sending a lot of them and from many devices, you need this no-schema database. It's almost like you're going to have a big data with that database anyway, and you're going to have a lot of data. And you need almost another kind of like a product for this, so it will make it easier to analyze the data. So Azure actually fits with all of those requirements I just count. So Cosmos DB can save all your data, and you can use many other products of Azure to actually analyze that data and do something about it. Whenever you get a weird signal from somebody, you can really use other applications of Azure to actually handle that easily. So another question I get usually from Cosmos DB about Cosmos DB is, why do we need another database? Don't we have enough products out there? which is a valid question. So to answer that, I usually give this example. So IBM actually had this research, I think it was 2017, and they found out that in last 2 years, and I'm talking about 2016 and 17, we managed to generate 90% of data in the world in 2 years. Computers has been out there for a long time, and we actually managed to do that. So you might ask, like, okay, why? So many people say that, yeah, we have the cloud right now, and that's generating all kind of data. That's true. But if you look at those numbers in the right side here, those are the numbers actually what happens on internet in a day. So, for example, 500 million tweets. Do you think that Twitter is using SQL Server to actually hold those data? Or look at the Facebook, 4 petabytes data. I don't think any relational database is going to handle that. So we need another database system which can actually handle numbers like that. So Cosmos DB and other NoSQL databases, usually companies use for traffic like that. Another reason, our applications are changing. Our applications are becoming more smarter, and customers are expecting more. And we have many other device types. Because of that, you might have one application, and it should work on the, your cell phone, for example. Well, usually your cell phone has a GPS, so you might be able to use the GPS and actually, make that application work a little bit different than desktop version. That means you're going to generate more data from the cell phone. And because of that, those features and different devices, applications are creating more data and consuming more data. Also, you might be one of those, developers, you find a way to actually fix a problem like everybody, having. So you have a simple application and you say, okay, it's ready, I'm going to put in production. So you put it in one of those Amazon stores or, Google store, wherever. And you wake up next day and you end up like users from all over the world. So I hope you picked the right database for that application because you're a global company now. And Cosmos DB actually can handle all of those problems very easily. So to understand the Cosmos DB, I try to explain actually how it works in the backend because there are a lot to talk about Cosmos DB, but it's not like SQL Server. In older days, SQL Server used to come like in a CD or a disk. You put in a disk and it asks you millions of questions and you click next, 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 and you kind of set up the environment for SQL Server. So you know exactly where the database was going, what the feature or what the settings were. You were able to change those. Well, in cloud, that is not the case anymore. So you kind of click a couple of buttons out there and you end up have a database. And you really kind of need to figure out what's really happening in the backend to understand how the system works so you can actually use it better. So what I'm going to do here is I'm going to try to explain you how it works in the backend. So I'm going to give an example. Let's say we are a company and we are located somewhere in Europe and we build cars. This year, we figure out that, many other car manufacturers, they are actually making smart cars and we don't have any. So we say, okay, let's try this. So we hire some dev team and we told them that, one of the models we want to actually create an application, IoT application in the car. So we can actually send data and receive data from the cars. So that is the idea. And our dev team look at the data and they say, okay, relational database is not going to do this because each sensor might be sending different schema. And later you might have different models sending whole different data. So we need a NoSQL database. And they look at the options and they said, well, let's give a chance to Cosmos DB, right? They're smart. So when you start to create a whole new application, Microsoft suggests that you should use SQL API. The main reason for that is SQL API is developed by Microsoft and they are in charge totally. So if you're going to need a new feature or have questions about how to use it, they are going to be able to, help you with SQL API more than others. If you're going to use, for example, Mongo, you're going to still depending on the Mongo because that's their product. So Microsoft suggests that we should use SQL API for this application. Say, okay, we go with that. So now our dev team start to work on it, and they create a Cosmos DB in somewhere in Europe. That's our headquarters. So as soon as our database came online, we end up with 99.99% SLA. That is a great number. I didn't have to do anything. That is the SLA that Microsoft guarantees to me that will be always online like that. So that is great. So after that, our dev team look at our sales data and they say that, okay, you know what, who's actually buying this car? They figure out that we have most of our people who's buying this car is from United States and Europe and some part of the Asia. So it was very clear. I mean, when you look at this picture right now, we don't want our users from United States or Asia to try to write data to Europe. The lag is going to be really high and it's not going to be a good connection. You might lose data. So this is not going to do it. So they look at the Cosmos DB, and Cosmos DB actually comes with global distribution, which means that you can actually use some other data centers wherever it's close to our users. And Cosmos DB will be able to, I guess, save the data and retrieve the data wherever our users are. So for example, let's say we have a user here close to New York, and our SDK is smart enough to pick which data center is the closest, and that user will actually write and read from this data center. And Cosmos DB will be in charge to actually sync that data in the backend. So all the data will be in, not maybe central, but all the data will be same at the end because Cosmos DB will sync all the data. As soon as we actually make this enable, so we pick 2 data centers in the United States, 1 in Asia and 1 in Europe. So we have 4 areas, 4 data centers. Our SLA actually went up to 99.999%. That's almost 100%. So really, that's great. Now, what else do we know about Cosmos DB? So whenever we save the data, so right now we are saving the data in 4 locations. And we know one thing, that all the data is getting saved in SSD drives and local SSD drives. So things are fast. Also, Cosmos DB, whenever it saves the data, it creates the physical partitions. Physical partitions are getting managed by only Microsoft, and you have absolutely no rights to change anything on physical partitions. So number of partitions depends on how much data you have. And as I said before, all these partitions getting synced in the backend, and each data center should have exactly the same number of partitions. So what else do we know about partitions? So if you look at a partition, and this partition you are looking right now has no global distribution. Let's say we have only in 1 data center. There is replica set in each partition, and we have a leader and 3 followers. If you look at that, that kind of explains you why Cosmos DB is a very, very fast database. Imagine that, a request comes in. A request can go to leader or the followers. So you have 4 options to get the data. And also, you have to kind of remember 2 numbers when you think about the physical partitions. The first one is 50 gig. That is the number that one partition can hold. So whenever you actually get close to 50 gig, Cosmos DB is going to give you another physical partition. Usually it doesn't wait until 50. If you reach like 75, 80%, you will end up with the second partition. The second number you need to know is 10,000 request units. That is the maximum request unit this physical partition can handle. If you are going to actually have, let's say, when you create your database, if you are going to say that you need 15,000 request units, you are going to have at least 2 physical partition, even if you don't have 50 gig. So those 2 numbers are kind of important to know. In our case, we have global distribution. So this picture is going to change a little bit because of that. So right now, we have Europe, we have United States, and we have Asia. So as you can see, one of the followers of replica set actually changes into forwarder. So whenever a change comes in, for example, to Europe, it goes to the leader, then it goes to each followers, and when it reaches to the forwarder is responsible to move this data to other data centers leaders. And in this way, that's how Cosmos DB actually syncs the data in the backend. Now, usually this is the point that I get the question, well, how good is this syncing data? Is it like, how is it actually, what about conflicts? Does conflict happen? It does happen. So for conflict to happen, you might have 2 users, maybe they try to insert the same exact data from 2 different locations. Or it can happen for replacing, updating, or deleting. So that can happen. So whenever conflict happens, we have a referee comes up and says that, whoa, 1 minute, there is something wrong here. Let's say we have the same data coming from 2 data centers, and they might be a little bit different than each other. So if you don't change anything, and if you go by the default, you are going to have the rule last write wins, which means whoever write the same data last time will win, and we will get rid of the older data. And we will say that, okay, we trusted the last write. Well, that doesn't always work for everybody. And if that's the case for you, you can actually have a custom setting for that. For the custom setting, for custom conflicts, what actually happens here is you create a store procedure and you register that store procedure as a merge store procedure. And what really happens here is that when a conflict happens, that conflict goes in a conflict queue. Then Cosmos DB is actually runs your store procedure that you just created, which you can I guess have all kind of business logic in it and all kind of workflow, and you can kind of merge the data as complex as you can write, and we will run that store procedure for that 2 data, and we will actually pick whichever to trust, and we will get rid of the other one. So you will be charged with that store procedure. So that's the second option that you can actually do. For the last write wins or the custom, if you are using the SQL API or any others really, Cosmos DB is using one of the virtual columns named _TS. That's the timestamp. And that's how it figures out like when it's actually written. If you are in SQL API, you have one option. You can change that _TS to another ID. For example, let's say you are having some orders in orders table, and 2 users try to maybe insert the same order from 2 locations. Rather than looking at the timestamp, you might be able to look at another numeric property, maybe order ID. And you can say that, okay, if the order ID is the highest, you can get that. So you can do that only in SQL API. If you have the others, then you have to use a store procedure. Next one. This one is pretty new, and this is about the storage. So whenever we get a transaction from any APIs, usually, most of the time we are using the transactional storage. That's where all the data goes. Cosmos DB came with another storage for us, and it's not available by default. You can change it if you like, and you can turn it on. So when you turn it on, what's really happening here is we get the data from any of those APIs in the left side. It's getting saved in the transactional storage in raw store format. Then Cosmos DB is actually responsible to move that data to analytical storage. Analytical storage in column store format, so it's very easy to kind of analyze the data. And the only thing is that to actually analyze the data, you must know the Spark API. So you kind of need to know Spark for that. And I don't really have that much experience with the Spark, but this option is kind of really great because that actually gets rid of the ETL requirements. Who likes ETL, right? I don't like ETL. Usually they break, and when they break, you have to go back and change them. And it can break because of code, it can break because of network connections, all kind of reasons I can give you right now. So by doing that, really Cosmos DB is almost writing its own ETL, and they are giving you guarantee that the data in transactional storage will be available in the analytical storage in 10 seconds, 30 seconds. That's a great number. Most of the ETL jobs I have right now sometimes runs once a day, maybe once an hour. So you are almost creating like this real-time environment. You can analyze your data. So that is great. And those also is giving the isolation between the transactional and analytical environment. So as you can see, the analytical transaction is cost you some money, but it can really help you if you need to analyze the data. And it's not really a good practice to kind of go to transactional database and kind of try to write reports or analyze the data in a way. And just like the other APIs, Spark API is the global distributed. And as you can see, those numbers might be changing. I think this is from the, I believe, last month. So just check those numbers again because those are coming from the Microsoft website. They might be changed, but they shouldn't be changed that much. So if we compare the transactional storage to analytical storage, in transactional storage, we have logical partitions, which I'm going to cover them in a little bit. But you have a limit with logical partitions, which is the 20 gig. And in analytical storage, you don't have any limit like that. In transactional storage, as I say, everything is row-oriented, so you can find the pinpoint and find your data. In analytical storage, everything is column-oriented. And analytical storage is using only this Apache Spark API, and rest of them is using the transactional. Default time to leave property is great for transactional storage. I use mostly for retention or sometimes caching the data. So for example, let's say your business says that after 2 years, I really don't care about this data. You can delete it. Then all you can do here is you can go and say put the 2 years for the default time to leave. And after 2 years, if nobody touches that data, Cosmos DB will delete that for you for free. That works for the analytical storage too. So you might maybe hold the data, for 5 years to analyze it. So you can have a retention period for 2 years for transactional, 5 years for transactional storage, and everything will be deleted for free from Cosmos DB. So you don't need to write all kind of syntax or any kind of code for that. So what does our database looks like? When you create the Cosmos DB database, the first thing you are going to actually have under a database is going to be a container. And those containers are SQL API, MongoDB, Cassandra, Gremlin, or Table API. Those are the options. You need to pick one of them. So whenever you create a database and when you come to the container setting, you should already know that which one to pick here. Depending which one you pick, the names under that might change a little bit. For example, after you pick, for example, SQL API, your data is going to named documents. If you pick, for example, Gremlin, your data is going to named node and edges. If you pick Table API, your items are going to named rows. Each container, doesn't matter which one you pick, is going to have all the items you see in the left side. Store procedures. The first thing you need to know about the store procedures in Cosmos DB is they are JavaScript. You have to know JavaScript to be able to create any store procedures, user-defined functions, or triggers. Those are in JavaScript. Also, the other thing about store procedures, if you think about, just remember that replica set I show you, and the leader was on the top, and we have 3 followers. Store procedures will always run in the leader. They will never run in the followers. That means store procedures are great for writing data because leader is always, busy with getting all the new data. So that makes them, fast when you write the data. But if you want to get the data from Cosmos DB, really store procedures are really not a good option because they run in leader, and leader has many other stuff to do. And if you want to just get the data rather than using the store procedures, you can use the user-defined functions. User-defined functions can run in the followers. So that's I guess, one tip I can give you. Triggers. Triggers are a little bit different than SQL Server if you compare a SQL Server. In SQL Server, they got fired automatically. In Cosmos DB, they do not. In SDK, you have to actually fire them manually if you have to. And you have 2 types of triggers, pre-triggers and post-triggers. Pre will run before the transaction, post will get fired after. Merge procedures, we just talked about them. They are the store procedures that you create to handle the conflicts. So that's really on one page what Cosmos DB, I guess, Cosmos DB's architecture. Like that's what a database look like, Cosmos DB database. All right, next is the internal. So we can compare those to the virtual columns of SQL Server. Those exist for every JSON document will have those properties. The first one is RID. That's the unique identifier. That's the record ID of a document. ETAG, I'm going to cover that in a little bit, so I'm just going to pass that for now, but it's for optimistic concurrency. The third one is the timestamp, and that just shows you the last time the data is updated. When is that? Underscore self is almost like the pinpoint of this data. So if you look at that, it's really look like a URL. So for example, our record ID here is this, I guess, let's say data underscore self. It starts with DBS. That is the record ID of DBS. So that's a database's name here. The second one is the collections, and that's the record ID of the collection. That is the document. That is the document's record ID. If you look at that, they are actually matching perfectly. So by knowing that, this is really, if you use the REST API of Cosmos DB, you're going to actually need to know this. And that is the pinpoint of the data in Cosmos DB. ID here is the only one you can overwrite. And if you don't override it, Cosmos DB is going to give some kind of number or some kind of data in here. And for example, if you are creating, let's say we create an orders table and we want to pick the order ID as ID. So you can actually override this ID and you can say that order ID is going to be my ID. You can do that. So as I said before, the ETAG I'm going to cover. So that's the ETAG. What is optimistic concurrency? So here's the definition out there if you want to read it. But if I try to explain that a little bit, let's say we have 2 users. And those 2 users are going to update an item, right? Let's say something important. Let's say we are actually going to update our customer's credit, right? So that's in the to-do list. And those 2 users actually open the same data in the same time. And they don't know that they are actually looking at the same data. So one of them might be in one office, the other one might be in the other office. So our first user is pretty fast. He just makes his decision, change the data. Our second user is not that fast and is taking time and kind of looking all the other stuff to actually make decision on it. The only thing he doesn't know, our user 1 is already changed the data. So whatever actually he is looking at right now is invalid. So to handle that in SQL Server, the devs usually what they do is they create a column out there, the updated date or updated by, and whenever you actually get the data to the front end, they get that data and they hide it under the forms, so user doesn't see them. So whenever user actually clicks a submit, that data goes back to the database, well, to the middleware. And the middleware is going to actually, before it does something and changes the data to database, it just compares that updated, for example, date. If the date is same, then that means nobody changed the data, so I can safely go and save the data. If it's changed, then the dev has to actually go back and tell to user that what, the data is changed, please get the latest and look at update it again. All that logic I just gave you here is really depending on the dev and it's manual. There is nothing in SQL Server to handle a situation like that. So it's really dev's responsibility to actually come up with a logic like that. In Cosmos DB, actually, they move that logic to the database level. So mostly those if match, if non-match, if modify since, those are really used by the browser mostly. For example, if non-match is used heavily by the browsers, so they won't try to get the page again and again because it's the same page that they are trying to load. So rather than getting it from the server, browser will cache it, and if the date always matches, then it will just deliver from the browser's cache. In our case here, if we are going to use if match, that is going to actually make, so if I actually go back here, as you can see, I have the E tag here. So when the user gets the data, we take this data to the front end. And when we click the submit, then we are going to actually pass this E tag. And if this E tag actually matches, then our transaction is going to go through. If it doesn't matches, then Cosmos DB is going to throw an error. And it's going to say that, what, I am not going to actually update this because the E tag doesn't match. So that is almost like a conditional kind of resource here. If non-match is the same way, and if non-match is working only for getting the data. And as I said before, it's mostly for caching. And if modify since, that is the date you're going to pass out there. And if it's modified since from that date, then it's going to get the data from the database. So those are kind of nice options, and you can use them from the SDK, or you can use them from the REST API. This page here is just showing the compliance, what is actually certified, Cosmos DB certified for. And in the United States, honestly, I don't know what those are for, but sometimes I used to be in healthcare. So healthcare is going to look, for example, for the HIPAA regulations. So depending where you are, you might look one of those, I guess, certifications you might need to, depending on your industry. So I don't really have that much to say in here. It's just a mostly reference. All right. So our next topic, which is pretty important in Cosmos DB, is partitioning. So when I start to talk about partitioning, usually I get questions like, okay, does it work like primary key of a SQL Server? No, it doesn't. In SQL Server, primary key makes things kind of unique, so you cannot insert the same data again and again to the same table, so it makes it unique. Or how about table partitioning? Idea is kind of same, but the way that we set it up in Cosmos DB is very different. And what can go wrong? A lot of things can go wrong if you pick the wrong partition. It's almost the first curve that you are going to actually take, and if you take it wrong, you're going to pay for it. Literally, you will pay for it. So whenever you are picking the partition, just like in other database, you want to be sure that the partition you pick, everything is going to be kind of balanced. You are not going to have like a one partition very kind of high, the rest of them is going to be low. If I try to give an example for that, let's say you pick the partition ID. Let's say we have an orders table, and you pick the maybe city as the partition. Well, if you live in the United States and if your city is kind of like not populated that much, you won't have any problems. Well, you're going to have problem with New York, for example, Los Angeles, right? There's going to be a lot of orders out there. So the balance is not going to be good. Also, each partition, as I say before, we kind of cover the physical partition. We're going to cover the logical partition soon. But each logical partition has a limit of 20 gig. That means you cannot have more than data in 20 gig in one logical partition. And when you pick the city as a logical partition, I bet New York and Los Angeles is going to have more than 20 gigs. And when you hit that 20 gig, you are going to be in big problem because you cannot repartition a database. So the only way to actually repartition, what you have to do is you have to create a whole new container, and with a different partition ID, then move your data from the old one to the new one. So sounds good. In the meantime, sounds expensive because you are dealing in cloud. Your data is in cloud. You are moving the data. You are paying for everything. So, and also, you for your dev team, whenever you change a partition ID, you might need to change a lot of code in your SDK and all of your APIs. So it can really break your solution and might cost you a lot of money that many people will just give up. So just be careful when you are picking the partition. To explain the partitioning a little bit, it's like organizing the data. So for example, look at this great garage. I wish my garage felt like that. So if I tell you, like, can you go and get one of those screwdrivers for me? You don't have to own this garage. You know exactly where that screwdrivers are, and it won't take for you to actually go and get it. It won't take that much time. Look at this closet. It looks great. So if I'm gonna tell you that go get me, like, I don't know, pants or shirt or shoes, you won't even think that much because it's right in front of you. And you don't need to kind of go and dig into stuff, and you know exactly where it is, and it's not even yours, right? So grouping stuff makes life easy. This is a better example. So I used to be in actually customer service long time ago, and I used to work in third-party shift, and I used to get those calls from technical services. Sometimes they couldn't log into their computers, and they say, oh, can you go and look at this computer? And I cannot remote in right now. And can you just, if you cannot log in, can you just reset it? Right? Sounds easy if you can find a computer. So if you go to data center, and if your data center is like that, yeah, probably it's going to be easy the job. But if it's not like that, sometimes it takes actually 10, 15 minutes to find the computer to actually click a button. So partition is kind of working like that. And unfortunately, if you compare a SQL Server right now, in SQL Server, what happens here is, we have devs and they create the tables. You'll be lucky if they put a primary key on it. So let's say they create a table and everything is working great. In 6-7 months later, the project manager comes to you and to the DBA and says that, you know what, everything was working great, but things are getting slowed down and we start to get tickets. What can we do? As a DBA, you look at it and you say, well, you don't have any indexes on this column, and you create them. Everything goes back to normal. Everything is working fast. Everybody is happy. Maybe, next 2 years or 3 years, project manager comes back to you and say that, you know what, everything was working great, but now we are getting more tickets. What's going on? So as a DBA, you look at it and you say that, well, looks like, we need some partitions here. So other way to explain this, we have to kind of wait until it gets slowed down to actually create the partitions in SQL Server. In Cosmos DB, it doesn't work like that. You have to actually create the partition in the beginning. It's going to give you the partition ID, it's going to give you the get question, and you have to fill it to actually create a container. And just don't guess that ID. You really have to study which one you should pick. You should look at your where clauses, and you want to be sure that that partition ID is always in your where clauses. at the end, partition ID is going to distribute all the requests. It's going to distribute the storage, and it's intelligently route queries for efficiency. And depending what kind of application you have, you want to kind of be careful when you are picking it too. For example, if you have a write-heavy, for example, IoT device, right? They're not going to read data. If it's write-heavy, then you might want to try to, pick a partition ID very, very unique. Then, and you can go to logical partitions and everything will work much faster. If it's read-heavy, you want to be sure that whenever you are reading the data back, you are going to able to create this partition ID, and you're going to always have it. Because if you have the partition ID and make that call, it's literally going to cost you cheap than if you don't have the partition ID. So as I said before, we talk about the physical partition, and to explain the logical partition, let's try to actually remember our example. So that was our example, and I actually show you the physical partitions here as a Lego block. Now I want to change that a little bit. Rather than Lego block, let's say our physical partitions are container ships. And this one has absolutely nothing to do with the container technology. Whenever Cosmos DB gives you a partition, it gives you one empty container ship. And it is your responsibility to actually put all the containers in this ship. Each container represents our logical partitions here. In our case, we are carrying cars. We are carrying the car's data. So Cosmos DB likes logical partitions small. It doesn't like big partitions. Because if you know the logical partition ID, you are gonna know exactly which container you need to go, get the data, or save the data. So another example, for example, we are carrying cars. So you can group those cars in many ways. You can group them by model. You can group them by, I don't know, color, year, and you can have larger containers. One container might have model X, other one might have model Y. But the problem with that is then even when you have the logical partitions, let's say the model, you still need to open this huge container, and you are going to end up with a lot of cars in it and try to figure out which one you need to go and get the data or save the data for. So in our case, what makes sense is the VIN number of a car. If you make the VIN number logical partition, and if you give the VIN number every time you try to get the data or to save the data, Cosmos DB is going to know exactly which container to go, open, and do what it needs to do. It's going to cost you much cheaper because Cosmos DB is going to lose less CPU and less memory to actually do that operation. So as I said before, the logical partition, another limit here is 20 gig limit. So that means each container can get 20 gig data. So if you think, for example, if you pick the model, for sure you're going to hit the 20 gig database, 20 gig limit. Then in that case, you might need to try to repartition it, and it's not going to be easy. Also, let's say this is our first physical partition, and it's getting almost, let's say, full. Then Cosmos DB is going to give you another one, another empty one. So what's going to really happen in the back end is Cosmos DB is going to start actually to move those containers to the other one. So everything will be balanced. So you won't have like one full and the other one is just like empty. So if your containers are smaller, that means Cosmos DB can move them faster. So the scaling is going to be much easier and much faster for you if you pick the logical partitions small. So rather than this example, let's show you another example. For example, e-commerce, right? Let's say we want to create a new market on internet. What do we have on market? We have users. We have orders of those users. Then probably we have a bunch of reviews coming from users, and we have shopping carts. So if you look at all those entities here, that's going to give you a lot of IDs to pick for a partition ID. For example, for users, you might have user ID, you're going to have a location ID. For orders, you're going to have order ID, product ID. Products is the product ID, product category ID. So when you look at that, it's much easier in Cosmos DB because everything is in JSON document to put all data in one document. So let's, for example, think about the Amazon. When you go to Amazon website and when you open it, first of all, you have to pick a category. Without picking the category, you're not going to see any kind of products that you want to see. That means you might need a container, which is going to have almost like some information about the products. Probably you're going to have like a product ID, some product description, and maybe the price. That 3 options. And that's going to be almost like you can call that, I don't know, product categories. That will be your container. So we are going to pick the product category ID as our logical partition for that, because we are always going to know that users are going to click on it. We are going to exactly know which category ID, so we can actually go and show all the products under that category. Now, after we open up, I guess, that page, now what is clickable is products. Then we are going to have probably another, container named products, and the ID is going to be probably then product ID, because that's actually what users are going to click this time. And that container is going to have very similar or maybe the same data. And that's going to have the product name, product description. Probably it can have some reviews in it. It can have the price. It can have all kind of other data that website actually needs to render the data. Because if you think about it, in Amazon, when you click a product, you really see all that data, usually in less than 2 seconds. And there are a lot of information on that page. There's pictures, there's description coming from the Amazon, there's description coming from the vendor, there's a lot of kind of reviews comes up, and Amazon doesn't stop out there. In the end of the page, it tells you what other products it has, just like this product, or it can show you what other people actually who buys this product. So if you think about it, there's a lot of things going on out there, and you need to get that data probably in 1 second from your database, so you can serve it to the user in 2-3 seconds. So if you can actually put all that data in one JSON document and make your product ID your logical partition, then you don't need to go and make many calls to database. You need to make one call, and you get all the data. And the other thing you need to be careful is just don't think about like how the relation database works. In relational databases, you don't want to take the data for same data and put it in the other tables. In Cosmos DB, it's a NoSQL database, so don't worry about if you need to kind of put, for example, product name and description to the product category container and product container. You have the same data in 2 different places. That works. Actually, that will make your bill much cheaper rather than you try to go to product and get the data from, because in product categories container, you always set the product category ID as a logical partition. You know that. As long as you know that logical partition, your query is going to cost you much cheaper. And storage is really cheap in Cosmos. It doesn't really cost you that much. If you worry about, well, what's going to happen if I go and change the product name, how do I need to go and actually change this in many other containers? Unfortunately, yes, but there are actually features out there that you can use that Cosmos DB can actually have some triggers. And when a product name changes, it can go and change in other places if you want to. So there are options like that. Just don't be scared about and try to kind of put the data only in one location. If you need to put the data in many locations, just do it, because it might actually cost you cheaper going that way than try to actually create like a master data management environment like you can do in SQL Server. All right, so Next one is IoT devices. So IoT devices can give you problems with logical partitions, because usually if you think about it, for example, the car that we are trying to create here, there's an IoT device in it, and probably most of the data is going to try to save to Cosmos DB is going to be about what is sensing, right? Because that's a sensor. So it might not have that much properties that you can use for a logical partition. For example, if your sensor is looking at, I don't know, the engine's heat or engine's oil level, I don't know, it's going to give you probably a couple of numbers, but that's it, really. I mean, you'll be lucky if that sensor actually knows the VIN number of the car. So you might have options. I mean, you might not have that many options with IoT devices. So if you want, I can give you one example here. Here's our Knight Rider. And in those days, you know, we thought that we don't have IoT devices, but hey, look, we have a bunch of them right there. So as I said before, they might not be, the data that they might want to kind of save the cloud might not be that useful for a logical partition. In that case, we are going to create synthetic keys. For that, as I said before, we are not going to have that much useful data that they're going to probably have. So all we know probably is we have the device ID and we have the year. And the rest of them, let's say all the kind of bunch of numbers. So what we can use here is, if we can use, you might say that, okay, what about the year? We can use the year. The problem with the year is, well, this is a Knight Rider, there's only one, but in the real life, you are gonna have a lot of other cars, and putting them in the same year is gonna cause hot partition. Because, you know, in this year, you might have, I don't know, 100 of this, maybe next year, everybody wants to buy this, you're gonna have thousands of it, and you're gonna have hot partition. So what we can do here is we can actually try to maybe to make it things a little bit more unique. We can try to combine those. So if we have only two here, what we can do here is we can try to combine them. We can make it Knight Rider and 1985. That makes it more unique. So we won't have that hot partition problem with the year anymore. And also, as I said before, in IoT devices, usually they're write heavy. And in this case, if you want to read this data later, you kind of need to, what partition ID you use. In this case, it's very easy to kind of recreate that. So I can recreate this and actually try to read the data. So that actually is good for the write heavy and read heavy applications. Next thing we can do, this one, if you don't worry about reading the data, what you can do here is you can say the Knight Rider and the year, and at the end you can add a random number, let's say from 0 to 200. Just pick randomly number when you are saving it. That will make things very, very fast. The problem with that is, well, your logical partitions are going to be really small, which is great. Everything is going to be fast. But whenever you try to read the data, probably you're not going to be able to guess this number. So your read queries are going to cost you much more. What else we can do is, well, we can actually still use the 1985 as a year, and we can maybe hash the VIN number. And you can still use this, and still you can create it for reading the data. So this is good for the write heavy and read heavy data. So usually this happens on IoT devices, but you might find yourself that, you know, you might have that much properties to use. So in that case, you might need to kind of be more creative and kind of combine some of the properties together here to, I guess, have a better logical partition. Well, that's all I have for you today, and I hope you learned something new today. And as I said before, you can reach me from any of those platforms. If you have any questions, I will be happy to answer. And that is my blog out there. And hopefully see you in the Data Platform Summit 2020. And it's going to be 24-hour. It's going to be round clock. And actually, I will be out there. I will have a workshop. And I hope to see you out there. Thank you very much. If you have any questions, I can answer now.
Thank you, Hasan, for a wonderful session and those wonderful examples as well. So friends, if you have any questions, please quickly put them down on the Q&A panel where the speaker would be able to take them down from there. And just one request, friends, I will be putting down 2 links on the chat window. One would be the event feedback and one would be the session feedback. Kindly do fill them out and it would really help us. It will really motivate us going further. So Hasan, meanwhile, would you want to speak about the session that you're going to deliver at DPS? Just a quick gist so that our audience is aware.
Sure. Yeah. So this is going to be my actual second one. The first one I did in SQL bits, and I got good feedback from it. And I have some updates for it. I'm going to show you some demos. I'm going to try to explain, what it knows. We are going to start from scratch, so you really don't need to know anything about NoSQL databases. I'm going to start from scratch. We are going to explain why we need them and how they can help you in your business. And we are going to show you how to develop them, develop the applications locally by using the emulator. And I'm going to show you how to migrate data from many sources to Cosmos DB. I will show you geospatial data, how to handle it in Cosmos DB. And change feed is another feature that many databases actually kind of jealous about. And with the change feed, I'm going to actually show you how to set it up for your databases. At the end, actually, I use a SignalR. SignalR is great too. And so will have like an example, for example, a security application. Whenever a sensor kind of gets fire and sends the data to Cosmos DB, change feed actually gets that change. And depending what sensor actually changed or fired, it can call the cops, it can call the fire department, it can do anything that we want. And I will show you how to set it up by using the Azure functions. Then from that point, we will use the SignalR, and that SignalR will actually, if you are the owner of that company, security company, you will have a dashboard. And as soon as you get something on your database, in your dashboard will just come up and say that, we had a problem and we had to do this one. So you will see everything in real time. So we will have different examples, great demos, and we will start from scratch. And as I say, as the name kind of, I guess, suggests, is from A to Z, Cosmos DB. I'm going to try to cover everything out there.
Great, Hasan. We are very looking forward to it, and I'm sure the audience too. So I don't see any questions in the Q&A panel, but if they do get in touch with us regarding this session and give us the question, we'll make sure to forward them to you post the event.
That's great. Thank you very much.
All right. Thanks a lot, Hasan, for taking out time from your busy schedule and delivering a wonderful session for the Data Platform Geeks community. See you soon. Stay safe.
Yep. Thank you. You too.